In this video, we're asked to write a method called hasPath that we're going to be adding to an int tree class later on. The method accepts two integer parameters, a start value and an end value, and it'll return true if a path can be found in the tree from the start value all the way down to the end value. So what does this mean? So for example, if we have the calling of 67 to 99, we can see, okay, our starting point is going to be equivalent to 67, so we need to check to see if a node contains the value 67. Then we need to traverse through the left and the right side of the tree to see if it contains the value, if another node contains the ending value here. So in this case, yes, 67 to 52 to 99. Now, if we decide to call the reverse of that from 99 to 67, because of the way we traverse through binary trees, we cannot go from the leaf node all the way back up to the root. It's just the wrong order. So we end up getting 99, 52 to 67 is not a valid path, so we will return false. Here's a little interesting thing I found at the bottom here. The reasoning for why 42 to 64 returns false is actually incorrect here. -1 and 45 do not exist in the tree, apparently, but we do see that a 45 does exist. What it's actually meant to say is that 42 and 64 do not have any do not correspond to any node value within the list. Okay, so if we deal with an empty tree, it doesn't have any paths, so we should just automatically return false at that point. So, and we're going to use a private helper method to help us get through this. So, first of all, the type is Boolean, because we're going to return true or false here to see as to whether or not there's an actual path we can go down. So, public Boolean has path. It's going to take in a start parameter and then an end parameter. What we want to do here is we want to return a private method. And our private method's going to do all the traversal stuff. So we're going to pass in an overall root so that we can get through the trees. And we're going to pass in start and the end values. So our private helper method is going to have a return type Boolean because we're returning it back up to our public method, and our public method has to return a Boolean type. So there we go. We're passing in an int tree node. We'll call it node. We're passing in the start value, and then we're also passing in an end value. Alright, so let's deal with the first case here. The very base case was to see if we're dealing with an empty tree. What do we do at that point? At that point, we want to return false because we have no possible path to look at. So we're going to do that by checking the node. So if the node is equivalent to null, meaning there's nothing there, then we just want to return false at this point because we know that we've looked through the entirety of the tree and there's just nothing else to look at. There's no possible path, so it's false. So one of the cases we want to look at is we want to find the start. And the way we're going to do that is by checking to see if if the node.data is equivalent to our starting value. Oops, cannot spell value. So we're going to say node.data equal to start. So if it's equivalent to start, that's good. What do we want to do at this point? Okay, let's change the start. We've already found the start, so now we need to search for the end value. So we're going to switch that to end. So at this point, we've already kept track of our start by checking the equivalent statement here. So that's good. What do we want to do after this, after we check this statement? Well, we want to actually work our way through these trees here. So we want to see if node.data is equivalent to start, and we want to see if node.data is equivalent to end. Oops. This special case here, we'll say, okay, so if we reach here and we change start to be equivalent to end, and we find that the data point for this specific node contains both the start and the end, will return true because there is a little special case on that I forgot to mention earlier. If the start and the end are the same, we're simply checking to see as to whether or not the node exists. So we get a trivial boolean, which will return true. So this test will say, okay, if the start happens to be equivalent to end, and we get that result, then we'll return true. Otherwise, we're going to start traversing down the left and the right side until we find that end value. So hasPath, we're going to traverse the left, we're going to plug in the start, we're going to plug in the end, and then we're going to traverse down the right, traverse down the right, hasPath, node.right, and start to end. And basically what this will do is this will keep traversing through the trees until it can find a path. So if we fail this test here, then we'll move on to this test. If we fail this test, we'll move on to this test. We need to divide that with OR statements. And 1, 2, 3. That'll be it for this video.